briefly in chapter 7 about there being risk to doing inference. And part of that risk comes from this idea of sampling variability. And so in chapter 8, we're going to look a little closer at the sampling variability so that we can understand the importance that it will play in the calculations for our different methods. So I want you to imagine that you're trying to learn about the proportion of women in a group of students. And so you see this picture, and we certainly could count the number of women in this group. So there's 19 women and there's 34 total people in this group. So the proportion of women in our population would be 56% or 0.56. But what if we didn't have the entire population? What if the population was millions of people? So what we would do is we would take a sample, a small group from that population, and we would look at that proportion and use that proportion to help us estimate for the entire population. And so you can see where this becomes risky because you can't get the entire population. It's just too big in many contexts. And so your population or your sample may or may not reflect the population. So if you look at the sample on the left of five people, 3 of them are female out of the total 5, so that's 0.6. But in the second sample, there were 2 women, and so that would have a proportion of 2 out of 5 or 0.4. And so neither of these was the true population proportion of 0.56. So we need to recognize 2 things when we're doing these sampling variability problems. That the sample proportion is going to be different for 2 different samples. It is every once in a while going to have the same characteristic for 2 samples, but almost always your samples are going to be a little different from sample to sample. And we also recognize in this particular case that we never got the exact population proportion. And part of that was because we simply didn't take a large enough sample, but even more than that, it's just uncommon and an unrealistic expectation for your sample to have the exact same value as the population. So this leads us to some questions. How much will the value of that sample proportion tend to differ from sample to sample? And fortunately, we know the answer to that, and we'll be learning about that in this chapter, so that we can use that known amount of variability in order to provide an accurate estimate. Now, we also need to ask how much will the sample proportion tend to differ from the actual value. Okay, and again, we have an answer to that we'll be using to help us form the foundation for these different methods. The third question is based on what you see in the sample, can you provide an accurate estimate of the population proportion? And in most cases, the answer will be yes, as long as our sample is representative of the population and that it is large enough. And we'll learn what large enough means later on in this chapter. And then finally, what conclusions can you draw based on the value of the sample proportion? So we'll be learning answers to all of these questions so that we'll be prepared in the following chapter, chapter 9, to start actually doing these methods of statistical inference.